Good morning, everyone. Happy Tuesday. Good morning. Hi, guys. Hello, hello. All right. Well, good morning. I am very glad that you are here. Thank you for coming. Oh, Stormy, you've got a cookie. What kind of cookie? Yum. All right. Well, yeah, me too. I love cookies. All right, guys. Well, let's go ahead and get started. Ooh, did you make them? Okay, awesome, Maddie. So today that's okay, Maddie, no problem. We are going to work on substitution, and then we're going to start elimination. Okay, so substitution is homework 5.05, and it's the 5.05 quiz that you were assigned yesterday. Okay, so today you will be able to solve a system of equations using the substitution method and checking your solutions. All right, this did not copy over like I thought, but let me draw for you what I wanted this to look like. So let's say we had a graph here, and our solution was like kind of in between two lines. The 5.05 homework, I'm sorry, there's no 5.05 homework. There's just 5.06. Sorry, there's a quiz for 5.05 and then a homework for 5.06. Sorry. Thank you, Anna. Sure, Anya, that's fine. Totally fine. That's okay. I hope you feel better. So, when we cannot tell exactly where two lines intersect, it doesn't do us much good to solve by graphing, okay, because we don't know the exact solution. So we are going to now, remember last week on Monday, I told you we were just working on writing equations. Tuesday, you were solving those equations by graphing. Okay, now we're going to learn other methods to solving systems of equations. So graphing is helpful to visualize the three types of solutions. Okay, I'm going to open up the room chat. Can y'all remind me what were the three types of solutions that we had? Anybody remember? We had one solution. What else? Anybody? Yes, Jonathan, good. One solution, no solution, or infinitely many solutions. Whoops, let me make that so you can actually see it. How about that? There we go. All right, so we could have one solution, no solution, or infinitely many solutions. So the lines, when we graph it, we can either see that they cross one time, that they're parallel, or that they're the same line, okay? The solution to a system of equations is the point where the lines intersect. Okay, and we write our solutions as an XY ordered pair. Like this. You can solve systems of equations using different methods, though. Okay, so graphing is not the only way. And like we saw on the previous slide, sometimes graphing is not the best way, because what if our solution is not a whole number? Today, we're going to show you how to solve systems using substitution. Okay, so here are the types of solutions. Again, just a reminder. We can have one solution, no solution, or infinitely many. So let's talk about substitution. When is substitution a good choice? Substitution is a good method to use if one variable in one of the equations is already isolated or has a coefficient of 1. So if you look down here at the bottom where it says example, both x and y have coefficients of 1, 1x plus 1y. And the second one, y is already by itself. That's what isolated means, is to get it by itself. So this would be a perfect time to use substitution because y is by itself or because x and y both have coefficients of 1. Substitution, we can use substitution for systems of 2 or 3 equations, but usually when we get to 3 equations in a system, we'll use a different method. But for now, we're going to look at substitution with 2 equations. So here are some steps. I'm going to pause for a second to give you time to write these or take a picture, and then I'm going to go over them. I know that sometimes steps are kind of hard to understand when you don't have a problem to actually work with. So that's why I just want you to focus on writing these down or taking a picture so you have it, and then I'll go over this. So I'm going to give you about 1 minute. That's fine, Adelina. Is going to be to solve an equation for one variable, okay? My advice to you is to pick the easier equation. So sometimes we'll already have one of the equations solved for a variable. So like in the previous one, y was already by itself. Okay, so in that case, step 1 is done. Then step 2 is where we're going to actually substitute. So we're going to put the equation we solved for in step 1. We're going to plug that piece into the other equation. Once we do that, we will have eliminated one of the variables. So now we're left with only one variable. So we're left with either x or y. And we're going to solve for that variable. Okay. We'll get a number. Step 4 is we're going to take that number and plug it back in to find the other missing variable. And then we can check our solution. I know that sounds like a little bit confusing, but let me show you now with a problem. So hopefully it will make a little bit more sense. Alrighty, so I'm going to cover some of this up as to not overwhelm you. All right, so it says solve the system using substitution. So I've got our steps listed out here on the left. This one says solve one equation for one variable. Okay, well, let's take a look here. We've got x plus y equals 5 and y equals 3 plus x. So the second equation is already solved for y. The second step is to substitute. So let me show you how we do this and why we're able to do this. This second equation says that y equals 3 plus x. So y is the same thing as 3 plus x. So anywhere that there is a y in this equation, we can instead put 3 plus x. So what we're going to do is say, okay, x plus y equals 5. We're going to change that to be x plus 3 plus x equals 5. All I did was take this expression, 3 plus x, that's the same thing as y. So since it's the same, I'm just going to plug it in for y. Is that okay with everyone? Is anyone confused or have any questions right now? Okay, good deal. So now step 3 was to solve the equation. As you can see, Erica, did you have a question, or are you saying yes, you're good to move on? Which one? Oh, sure. Okay, what's your question, Erica?
Can you hear me?
Yes, I can.
Okay, so I had a little bit of trouble at first we're plugging in the variable. So for solving for x, you take the y-x, where it's like below the, I don't know, it's kind of confusing. You know the 3? So we just take the 3 and place it into the equation, like plus x on the first equation, because it's a little confusing.
Okay, so right now we have y by itself up here. It says y equals 3 plus x. So this is saying that y is the same thing as 3 plus x. So anywhere that there was a y in this top equation, I can replace it with 3 plus x because they're the same exact thing. So this was my original equation, x plus y equals 5. Now, I'm going to pretend like I'm not allowed to use that word, that I'm not allowed to use y. So I have to think of something else. Oh, well, y is the same thing as 3 plus x. So instead of putting a y, I'm going to plug in 3 plus x because they are the same. Okay, so now remember I told you that we're going to solve the equation because we're going to only have one variable left. That's what we're trying to do. Yes, exactly, Erica. So we wanted to get to have just one variable. So x plus 3 plus x. I'm going to combine my like terms. So I have x and x. So 1x plus 1x is going to become 2x. So I get 2x plus 3 equals 5. All right. Now, again, I only have one variable left, and that variable is x. So I'm solving for x. So this goes back to what we did in Unit 1, well, Unit 0 really, of this semester. I'm now going to subtract 3 from both sides. Yeah, you just add x plus x because they're like terms. So I'm going to subtract 3 from both sides. So I get 2x equals 2. Now I'm going to divide both sides by 2. And I get x equals 1. So the first part of my solution says that our x value has to be 1. Okay, questions about how we got to x equals 1 on this slide before we move on. So we're not finished yet. We've only found the x value, but a solution is an x and a y. So now we have to find the y value. But before we move on, I want to make sure that we don't have any questions. Okay, so let's now go to step 4. Step 4 says to plug back in to find the other variable. Okay, remember on this previous page, we just said that x was equal to 1. So instead of an x, I'm going to put in a 1. So I get y equals 3 plus 1. Let me finish this one and then I'll show you. So we could do y equals 4. If you wanted to plug it back into the top equation, let me show you here, you would still get the same number for y. Y is still equal to 4. Questions about how I found y? You can plug it into either equation because they're both the same. It's a system, so they're working together. Okay, the 1, Richard, came from this first 3 steps that we did. We solved for x first and found that x is equal to 1. So we took our y equals and we substituted it in. That's why this is called the substitution method. We subbed in y, where the y was, we subbed in 3 plus x. So we put a substitute in for y. Good question. Yep. Well, remember I said that we're not finished yet because a solution is an x and a y. Okay. So then if you wanted to check your solution, we are saying that the solution is 1, 4. So I'd put a 1 in for x, a 4 in for y, and make sure I get 5. 1 plus 4 is equal to 5. 4 is equal to 3 plus 1. So the solution, therefore, is 1, 4. Let me ask you this question here. What do you think the answer would be if we decided to graph these 2 equations? What would our solution be? Anybody? Okay, yes, Richard, the point where the lines cross. And what do you think that point would be? Remember, this is just another way to solve. The solution is still going to be the point 1, 4. Okay, so remember when we were talking about graphing solutions or graphing systems to find the solution, we had said that there was 3 possible things that could happen. Okay, we could have 1 solution, no solution, or infinitely many. We can still have all 3 of those when we're using the substitution method. Okay, here's how they look. When you have 1 solution, it results in 1 value for x and 1 value for y. For instance, that's what we just did. We got 1 for x, 4 for y. With substitution, you're going to get when you go to solve for one of your variables, you're going to get a totally false statement, such as 4 equals 9. Angel, you'll have to go back and watch the recording to get the beginning, okay? We're on 5.05. Such as 4 equals 9. 4 does not equal 9. So if you get an answer that says 2 equals 6, then that means there is no solution. Then for infinitely many solutions, you're going to get a true statement. So 4 equals 4, 2 equals 2. Okay, if you get the same number equaling the same number, that's when it's infinitely many solutions. And what we're going to do now is go through some problems where we're going to see these different cases. So let's go ahead and try this one. This is question number 1. Solve the system using substitution. Write your solution as an ordered pair. Check your solution. So this is another one of those really awesome things about finding solutions is you can always check your answers. All right, so remember, we want to get one of these two equations. One of these two. Yep, I'm going to do it with you. We want to get one of these two solved for x. So we're looking for a variable that has a coefficient of 1. Does the top equation have a variable with a coefficient of 1 or the bottom? What do you think? Take a look. What do y'all think? Which one has a coefficient of 1? Either a 1 in front of 3 or in front of y or a 1 in front of x. Remember, it's not always written, okay? If it's not written, if there's not a number written, we can assume that it's a 1. So what do y'all think? Yeah, Jonathan, good. Anybody else? What do you think? Y'all got to work with me here. Do you think it's the top or the bottom? Just vote. Either one, top or bottom. Yes, good. The top. So right here, this is 1x. Good, Anna. Thank you. So we want to get x by itself. So what I'm going to do is come up here, and I'm going to solve the first one for x. So 3y plus x equals 7. I'm going to subtract 3y from both sides. So x is going to equal 7 minus 3y. Well, we're not saying that x equals 1, Richard. We're saying the coefficient of x is 1. Okay, so now that that was step number 1. So now what we are going to do is take this equation. This says that x is the same thing as 7 minus 3y. So I'm going to now plug in to this equation. Instead of putting in x, I'm going to plug in 7 minus 3y. So let's write it out. I would have 4 times 7 minus 3y. We have to put it in parentheses. Minus 2y equals 0. I'm going to pause. Tell me if you have questions. Yes, Jonathan, that's exactly right. All right, so now this is where we're going to use our skills from Unit 1. We are going to distribute. So I'm going to do 4 times 7 and 4 times negative 3y. So 4 times 7 is 28. 4 times negative 3 would be negative 12y. Minus 2y equals 0. I am now going to combine like terms. Negative 12y minus 2y gives me negative 14y. I'm going to add 14y to both sides. So 28 equals 14y. Divide by 14. So the y value then is going to be 2. I'm going to pause here to let you catch up. Tell me if I lost you on any of these steps. I'm going a little bit quick on the solving for y. only because that's just a skill from Unit 1. But if I lost you anywhere, let me know, okay? Good, Angel. So Richard, you can see that you were correct. Your guess and check was right. Okay, Anna, no problem. So, do you understand how I got 28? Okay. So, I plugged in 7 minus 3y up here. I plugged that in for x. So, I came to this bottom equation here. Instead of putting in an x, I plugged in 7 minus 3y. So I get 4 instead of x, right? I'm just rewriting this equation, but instead of x, I'm going to put 7 minus 3y. I have to put it in parentheses because this is 4 times x. Okay, so since I have two numbers here, I'm going to put it in parentheses. So 4 parentheses, 7 minus 3y. Yes, and then I use the distributive property because now I want to solve for y. So I multiplied 4 times 7 to get 28 and 4 times negative 3 gives us negative 12y. All right, and then I just kept solving. I combined like terms, so negative 12y minus 2y would be negative 14y. Then I moved that negative over to the other side because I want to get y by itself. So I added 14y, so now I'm dealing with positive numbers. So I had 28 equals 14y. I'm going to, again, I want y by itself. So I'm going to divide by 14. And then I get y equals 2. But remember, we're not finished, okay? We need a value for x and a value for y. So the next thing we need to do is take this y value and we're going to plug it back in. So I'm going to plug it in the top equation and I'm going to solve for x. So 3 times 2, because instead of y, I know that y is the same thing as 2. So 3 times 2 plus x equals 7. 3 times 2 is 6. 6 plus x equals 7. Again, I'm solving for x now. So I'm going to subtract 6 from both sides to get x equals 1, which makes our solution to this system the point 1, 2. Questions so far? All right, let's try another one. We've got x equals 3 minus y and x plus y equals 7. Well, lucky for us, this one is already by itself. So I don't have to solve any of these for x or y to get started. Now I'm going to rewrite this bottom equation, but instead I'm going to plug in 3 minus y for x. So I'm going to say 3 minus y plus y equals 7. Anybody confused on how I got that? It's totally okay if you are. I just want to be able to explain it. Okay, Richard, 1 second. I'm trying. My computer is like freezing up on me. Sure. What's your question, Richard? Go ahead.
If I understand this correctly, 3 minus y plus y equals 7. Wouldn't the minus y and plus y cancel each other out?
Exactly. Exactly. So let's go ahead and do that. Negative y plus y. Those are going to cancel each other out. So I'm left with 3 equals 7. 3 does not equal 7. So therefore, you're exactly right, Richard. This is an example of no solution. Okay, so that would mean that these lines are parallel. All right, let's do another one. 3x minus y equals 4. And then we have x equals 4y minus 17. Okay, lucky for us again, x is already by itself. So I'm going to take this 4y minus 17 and plug it in for x. So, whoops, let me use a thinner marker so it doesn't get crazy. So we've got 3 times 4y minus 17 minus y equals 4. All right, now I'm going to distribute. So when I do that, I get 3 times 4y, which is going to be 12y. Then I get 3 times negative 17, which is negative 51, minus y equals 4. Okay, and then I'm going to combine my like terms. It's a 51. So the way I got 51 is I did 3 times negative 17. So 3 times negative 17 gives us negative 51. Good question. All righty. Now I'm going to combine like terms. So I have 12y minus y. So 12 minus 1, 12y minus 1y would give me 11y. So I get 11y minus 51 equals 4. Okay, now I'm going to solve for y. So I'm adding 51 to both sides. $11y equals 55. What's my last step going to be here? Anybody? What's my last step? Good, Richard. Nope, you're right. That's exactly right. We're going to divide everything by 11. Very good. Good. Good, Jonathan. Yep, good, Angel. Good, Antoine. So y equals 5. Questions about how I got to y equals 5? Okay, Anna, what's your question? So I don't know that it's always y. Sometimes, I think it was the previous one, like we were solving for, just depends. The first one I think we did we solve for x first? It's not always y, but what we want to do, since this time we did solve for y, because x was already by itself. So you're just going to use the one that is the easiest. Okay, so can y'all tell me in the room chat, now that I have a value for y, what is my next step? Remember, we have to have an x and a y. Good, Jonathan. Yes, Angel, good. We have to have a value, a number for x and a number for y. So I'm going to take 5, the number 5, and plug it in for y. So I would get 3 times x minus 5 equals 4. I'm now going to solve for x. So I'm going to let y'all do this one by yourself. What I want you to do, don't tell me just what x is in the chat. I want you to tell me in the chat the solution, and I want you to write it as an ordered pair. So put it in parentheses, x comma y, but you're not going to put x and y. You're going to put numbers. If you get a little stuck, totally okay. Just send me a message. Good, Antoine. Good, Sophie. Good, Erica. Angel, x is not an exponent. X is a variable in this situation. Good question. It's a variable. Okay, it's not. Nope. Just a variable. Anybody else got it? Are we stuck? What's going on? You could have a variable as an exponent. You won't until probably algebra 2 or calculus. All right, so we're going to add 5 to both sides. So we get 3x equals 9. Divide by 3. So x equals 3. So then our solution is 3, 5. All righty, let's do, whoops, we already did that one. All right, we are going to finish with this question number 4. I'm going to let you work this one by yourself. You're going to send me a private message in questions and answers when you get your answer, and I'll let you know if it's right or wrong. And if it's correct, you're free to go. If it's incorrect, then you'll stay and watch how I solve it. Okay? Actually, let's do this one. This one will be just a little bit easier for you. So I'll give you a hint. We're looking for one of the variables to have a coefficient of 1. Here it is. So the first thing you're going to do is solve the top equation, 2x plus y equals 20. Go ahead and solve that for y first. And I'm going to pause. If you are stuck, send me a message and tell me what you've done so far or where you're stuck, and then I can help you get going again. Yes, Angel, that's right. So your y is going to be 20 minus 2x. Okay, Anna, can you tell me where you're stuck? What's going to be your first step? I rewrote the equation up here at the top. Okay, so we already identified the variable. Yep, I highlighted it for you. What variable? Yep, you're solving for y. So how are you going to get y by itself? What's the thing you need to do first? Yes, Richard, you are correct, but you've got it. So you are good to go. So Anna, if this is y, I want it by itself. What is next to this y right here? What am I doing? Yeah, there's a 2x, and what am I doing? Am I adding, subtracting, multiplying, or dividing? Okay, I'm adding 2x, exactly. So I want to undo that. The way that I undo that is I do the opposite of adding 2x. So what would be the opposite of adding 2x? So you're going to subtract 2x from both sides. Yep. So for anyone else that's stuck, you would get y equals 20 minus 2x. Okay, so now what you're going to do, x is not, Angel. Not quite. You are going to take this 20 minus 2x, and you're going to plug it in to this y. So you would have 6 times x minus 5 times, yes, Lanaya, exactly. Good job. 20 minus 2x equals 12. So all I'm doing is plugging in, I'm substituting 20 minus 2x, I'm substituting that for y. So now, Anna, what you're going to do is you're going to distribute. Okay, you're going to multiply negative 5 times 20 and negative 5 times negative 2x. Yes, Angel, there you go. Okay, Anna, so what you're going to do is you are going to substitute, you're going to multiply negative 5 times 20 and negative 5 times negative 2x. Yes, Angel, you're right. Okay, Anna, what are you confused about? So once we get to this step here, where we plugged in, what I've been saying, I don't know if maybe you're just confused. We are multiplying negative 5 times 20 because this is where we have to distribute again. So we have to get rid of parentheses. That's order of operations. PEMDAS. I don't know if you remember that from your previous school. We have to get rid of parentheses. We have 20 minus 2x. We have to get rid of that. Okay, so we have to multiply this negative 5 by 20 and by negative 2x. So what is negative 5 times 20? Go ahead and put that in your calculator. Anybody else have the answer? Only 2 people? Are y'all sleeping on me? Good, Antoine. Good job. You're free to go. Good job. Yes. Good, Anna. So negative 100. Not quite, Mason. And then, Anna, what's negative 5 times negative 2x? Sophie, you've got it. You just switched the order of your X and your Y. So go ahead and switch that order, and then you've got it. Yeah, Kyra, that's right. Good, Sophie. Okay, good, Anna. So we get 10x. Don't forget your x. Equals 12. Now we're going to combine like terms. So 6x plus 10x. What is 6x plus 10x? Yep, 16x. Very good. Okay, now again, I'm solving for x, so I want x to be by itself. So what's happening right now to 16x that I need to undo? How do I get 16x by itself? Just read it out loud to yourself. So that's what's happening, right? 16x minus 100. So what's currently happening is I am subtracting 100. So we need to do the opposite. What's the opposite of subtracting 100? Good, Mason. Good. Okay, so we're going to add 100 to both sides. So 16 times x equals 112. And then, Anna, what would we do to get x by itself? We have one more step. Yes, divide by 16. Okay, and when we do that, what do we get for x? X equals... Yes, good, Anna. So x equals 7. Okay, good. So now we've got a value for x. So what should we do next? Now we need to find a value for y. How are we going to do that? Very good. So let's plug it into this top one here. So I'm going to do 2 times, instead of x, I'm going to plug in 7. So 2 times 7 plus y equals 20. All right, 2 times 7 is 14. So 14 plus y equals 20. How do I get y by itself? Yep. What am I going to subtract? Yeah. Good, Lelaine. Yes. Good, Anna. Subtract 14. Very good. So then y would be 6. So that means our solution here would be 7, 6. Yeah, of course, anytime. All right, guys, that's all we've got time for today. I'm sorry that I went a little bit over. If you have any questions, please feel free to email me. I think I got caught up on the grading. Oh, sorry, I didn't even realize my camera. I will try to get caught up again today with anything that's been turned in. And we are going to have small group on Thursday and 2 small groups on Friday. Okay, so please come to those if you feel like you need some extra help or need help going through some homework problems, okay?